cool. So I've titled this 7.1 vocabulary, and it's really just kind of going over the necessary ideas and concepts that we're going to need for the rest of the chapter. Topic 7 is all about angles and angle pair relationships, parallel lines, stuff like that. So, yeah. All right, cool. Here we go. A formal definition for an angle. All right. Angles are made up of two rays with the same starting point. This point is called the vertex. Bless you. To name an angle, there's a variety of different ways that we can name an angle. Some of them are more common than others. And a really easy way is that when we're given an angle, and that angle just kind of has an identifying number in it, like angle 1, bless you. Here is one way to name an angle. It might just have like a number in there. We'll just call it by that number. The most common way to name an angle is to use 3 letters. So let's say I have a line with a ray coming off of it. And I am labeling angle ABC. So I'm going to kind of trace it, right? So from A, I trace to B and then to C. The middle letter in this is always going to be the vertex letter. So I could name this angle ABC, which would be identifying this angle here. Or I could name the same angle CBA if I was going to name it with 3 letters. The last way would be just to name it by just the vertex. So then we might consider, when we're looking at this kind of red diagram here, why can't we just call this angle B? And the reason is because it's not specific. So if I were to just name this by the vertex angle B, I don't know whether I'm talking about the big angle on the left, the smaller angle on the right, or the whole straight angle. So it just has to be more specific. Congruent angles. Congruent angles have the same measurement of angle. So we are used to measuring angles in degrees, and that's what we've done in math up through math 2. Depending on what math class you go to next year, you will most likely be introduced to a way that we measure angles called radians. But for now, we just use degrees. So if I were to write a congruent statement, I'm going to give some letters to these angles here. Let's call this A and Z. And if I wanted to say that these angles were congruent, I could say angle A is congruent to angle Z. Some reminders: the congruent symbol looks like an equal sign with like a little wave on top. And I always draw my angles marks with an arc across them, because sometimes when I'm writing fast and I write an angle mark like that, it kind of looks like an L. And so I always draw an arc on it so that it's clearly an angle mark. And that's just because I think my writing can be confused for students. And so I just clearly, that's how I do it. It's okay if you don't write the arc on it. Cool. All right, vertical angles. So we do have the vertical angle theorem here, but we also need to define vertical angles. So I'm going to do that kind of over here. Vertical angles are opposite each other when two lines cross. Vertical angles are opposite each other when two lines cross. And actually, when I have two lines crossed like this, I have two pairs of vertical angles. So in the image here, I have the ones that are marked in this orange, and then I would have the two that are unmarked are also vertical angles. What the vertical angle theorem says is that vertical angles are equal, or they're congruent. I'm going to add some letters to this picture so we can write a congruent statement. So just a little practice with writing congruent statements or equations today, just to get us warmed up. So let's say I wanted to say that those marked angles were congruent. So let's call the first one, where do I want to put this? I'm going to write it right underneath here. I'm going to call it TEA. Angle TEA is congruent to. Oh, I'm sorry. That's an error. I said the ones that were marked. Let's go for TEC. I said the ones that were marked, and then I named a different angle. All right, so TEC is talking about this angle, which is also marked angle A. And I want to say that that's congruent to an angle over here. When I name the other angle accordingly, it's going to be angle HEA. I could say the angles are congruent or their measurements are equal. Complementary angles are two angles that have a sum of 90 degrees. A sum just means that they add up to 100, or I'm sorry, that they add up to 90. The picture that's drawn for you has two angles, a 40 and a 50 degree angle, that are next to each other. They share a leg, or they share a ray here. We call that adjacent. But complementary angles could also be not adjacent. They could also not touch. So here's a different example. And I'm going to give these some letters so we can write another sentence. So complementary angles could share a side or not. And these angles are not equal, but they do add up to 90 degrees. So if I wanted to write a mathematical sentence here, I could say angle YES plus angle NOP is equal to 90 degrees. All right. On the next page, you'll see the supplementary angles. Complementary are two angles that have a sum of 90. Supplementary are two angles that have a sum of 180 degrees. Just like complementary angles, supplementary angles, they could share a ray. So on this top picture here that's got orange on it, the 40 degree angle and the 140 degree angle are supplementary. They add up to 180, and they're adjacent. They share a side. Or they could be separate. They don't have to touch. We've used the word adjacent a lot when we were doing trigonometry. But here is just another formal definition as we use it when we're talking about adjacent for angles, and specifically is two angles are adjacent when they have a common side and a common vertex. So let's see, ABC is adjacent to CBD because they share this ray and this vertex. Adjacent. And then talking about a linear pair. A linear pair are two adjacent angles that make a line. Their sum is 180 degrees, just like a line. Let's write another sentence here saying that one of these angles plus the other angle is equal to 180 degrees. Now, I could name this larger angle LMN, or I could name it NML. They're the same thing. Let's go for angle NML. And then I can add that to the other smaller angle. I just like to trace it sometimes. PMN, to make sure I get them in the right order. PMN. And when I add those together, I would get 180 degrees. Two of these concepts that we just talked about are really similar, so I want to go over them again and kind of show similarities and differences. So a linear pair by definition is two adjacent angles that make a line. They add up to 180. But let's go back up and look at supplementary angles again. Supplementary angles are two angles that have a sum of 180. Now, these could be adjacent, and then they are supplementary, but they're also a linear pair, or they could be separate. Any two angles that add up to 180 are supplementary. If they're adjacent, then they're also called a linear pair. So a linear pair is always supplementary, but supplementary is not always a linear pair. So just one more time, supplementary angles just have to add up to 180. If they're connected, they are also a linear pair. So this is also a linear pair. And it can be both things. That's okay. Okay, that's actually it for this, what I'm calling 7.1, this introduction to vocabulary. It doesn't align exactly with 7.1 in the book, but this is what I'm calling our first lesson.